We will have a little bit of theory followed by practical. Not much. Hmm? We have introduced 7 new terms in the morning session. Can anyone repeat with me? Binary, octal, decimal, hexadecimal, and all XOR. Super. Okay. Then bitwise AND. We have explained how bitwise AND works. We have compared 3 and 7 using bitwise AND operator. It resulted in 3 as the result. Then bit L shift, left shift. When we left shift the number, one vacancy is created and the vacancy is filled up using 0. But we shift all the digits to the left by one position. Then the first one will become blank. You have to place a 0 there. I said when 3 is left shifted, it becomes 6. It is equivalent to multiplying by 2. Multiplying by 2. Good. Then bit R. Bit R means similar to AND, whereas you have to apply the OR condition. Either 1 or 0, true and false, is also considered as true. Bit R. I take the same case now. I compare 3 and 7 using bit R. You just take a look. 3 in binary notation 0011 and 7 in binary notation it will be 0111. Okay. Now I compare it using bitwise OR. This is the bitwise OR operator. Then the first two are true. True or true. Both are true. We accept it as true. I have to start from here. Okay. Or from here. Okay. Whereas it's logical, you start with the last. This is 1. Then 1, 1. Again, it is true because both of them are 1. Then 1, 0. This is also true because at least one of them is 1. Therefore, we place 1 here. Then 0. 0, 0. False and false will be false. Therefore, through comparison, we found that the result is 0, 1, 1, 1, which means we have 7 in our hands. Because how to evaluate this? First digit, this one is 1. This one is 2. This one is 4. 1, 2, 4, 8, 16, 32. I told you the progression. It's geometric progression multiplied by 2. Each one is multiplied by 2. Now, 2, this is 1 plus 2 plus 4. 7 again. We get 7 as the result using bitwise OR operator. Then XOR. If bit XOR here. 8th one is bit XOR. Okay, I will tell you what it is. Then bit OR shift. Now I take 7. Whose value is 3. I will take 3 as the input. Then 0011. This is the normal number. I have to right shift it now. I told you in the earlier case, I have shifted Princey out of the chair. I have shifted both of you and then inserted Shanman. Now I take out Nalini. I shift both of you to the right and then I take Aishwarya to this chair. Similar to that, here we have to shift everyone by one location and the last one will be 0. I right shift it or shift. What happens when I right shift? The last, there are 4 digits, 4 decimal places. The first one falls away. This one will be deleted because it goes out. It's like the last person. You have to take that person to the other chair, other desk. You are not considered in the present desk. Therefore, this one will be removed. I place 1, 0, 0 and I have one vacancy at the left end. I have to fill it with 0. Then we started with 3. We ended with 1. Okay, it's equivalent to when we right shift, It is equivalent to dividing the number by 2. When right shifting a number, we get a result which is equivalent to dividing the number by 2. 3 divided by 2 is 1.5. Whereas in integer arithmetic, we don't have any fractions. Only 1 will remain. That is the result we get here. What happened was, this one is knocked out. This one is knocked out. And a place is created on the right hand. I place 0 here. Okay, this is what happened. Look, that is the result we get. 00001. Okay, for 4 decimal places, we got 000 and 1. It's equivalent to 1. Okay, when left shifting a number, you get equivalent of multiplication by 2. When right shifting a number, we get the equivalent of dividing the number by 2. Okay, integer equivalent of dividing the number by 2. Okay, now we come across the most interesting operator, bit XOR. Bitwise XOR. We will see what bit XOR does. It's like a psycho, I already told you. It says there should not be true and true. There should not be false and false. There should be one true, one false. The rule is one should be true, the other one should be false. We take again our own 3 and 7 for bitwise OR operation. I place it here 3. And we get 0011. It's 3 in binary notation. Then 7. We get 0111. Now we move on to bitwise XOR. Bit XOR. Cap symbol represents XOR operation. XOR for exclusive OR. Okay, we start with the last. The rule says true and true will be false. Then 1 and 1 will be treated as false. You are not permitted. 1 and 1 cannot be permitted. It's like a psycho. Then 1 and 1 again. It's not permitted. Then 0 and 1 permitted. One is true, other one is false. Then 0 and 0, false and false, not permitted. It means through XOR, we arrive at 0100 as the result. We arrive at 0100, which means we have 4 in our hand. Through XOR operation of 7 and 4, 7 and 3, we end up with 4. Because this is 1, this is 2, 1 and 2 are absent. Therefore, these are 0, therefore 1 and 2 are absent. Then 4 is present. Through 1, 4 is present. 4 is the resulting value. We get 4 as the result for exclusive OR operation performed upon 3 and 7. Okay, it's simple. 1 and 1 will be 0. 1 and 1 will be 0. Whereas 1 and 0 or 0 and 1 will be 1. That is the reason why we get 1 here. 0 and 0 will be 0. Okay. I told you XOR is like a what? Yes. It has got its own peculiar rule. Out of the ordinary. Psycho normally meant a person out of the ordinary. Psychological passion. Whereas now it has become something synonymous with a person who terrorizes others. Okay, a person psychologically disturbed was called psycho at the beginning, whereas nowadays it has been used for several other things. Whereas it's out of the ordinary. That is the reason why I told this term. Whereas nowadays cinema has managed to bring about a new meaning to this one. This one. Okay, XOR. Then we have used all the 3 comparison operators and, OR and XOR. Okay, then convert. What does it mean? Convert means conversion. What? From Hindu to Muslim, from Muslim to Christianity, from Christianity to some other religion. Convert. Similar to that. Here also, convert means what? Convert means you convert a number from one given unit to another unit. You have some number. I say this is the length of this table is 3 feet. Convert from one unit to another. I say this is about 3 feet in length. Whereas I want it in meter. I can say convert 3 Machar. Do the words wrong, sir. Listen. What is conversion? Conversion is from one unit to another. I say 3 feet, and I wish to convert it into meter. I may convert the number into meter, 0.9 meter. This will convert the number, given number from one unit to another. I have to say 3, comma, ft, comma, m. 3 is the number. Ft is the original unit. M is the new unit. Then I will get 0.33 or 0.3 something like that as the 0.9 as the result. Converted result. Then take to bin, decimal to binary. We know this. We give some decimal number, it converts the number into binary. Take to hex, decimal to hexadecimal. Then take to oct, decimal to octal. Okay. Then delta is the function, test function for comparison of two results. Okay, if two results are equal, it gives 1 as the result or true as the result. If they are different, it will give false as the result or 0, number 0 as the result. Then hex to bin, hexadecimal to binary, hex to hex to bin, then hex to dec, hexadecimal to decimal, hex to oct, hexadecimal to octal. Okay. Then complex. What is complex? Complex number. Have you ever heard of it? Imaginary number or complex number? Yes? No? Complex number. 3 plus 2i. You would have seen it in 10th standard. 3 plus 5i. 4 plus 2i. There will be one real part, one imaginary part. These two combined together would be called what? Complex number. It's similar to x comma y in our graph. We write x as the real part, y as the imaginary part. Okay. Complex. Then IMAX, imaginary absolute value. It's squaring of real part, squaring of imaginary part, and addition of these two take square root. It's imaginary absolute value. Imaginary part alone would be taken as imaginary. You offer one full complex number, you take out the imaginary part, imaginary. Real. Real stands for take out the real part. Then oct to bin, octal to binary, octal to decimal, octal to hexadecimal. These are the conversions. I'll show you how some of these functions work. Okay, some basic functions. I'll show you how they work. With that, we will close theory portion. I'll not use all the functions. I will show you some sample functions for your understanding. I say 15, sorry, 13 as the number. Then I call decimal to hexa, dec to hex as the function. A1 is the input. I should get 13 is A, B, C, D. I should get D as the result. D is the result. I told you in the morning, after 9, hexadecimal will have 15, 0 to 15 as the number digits. Okay. 10 is written as A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay. Then, okay, you can use any other function similar to this. Okay, here 13. For 13, okay. Okay. Take to bin. I call deck to bin A2. 1101. I say 7 and deck to bin 111. I told you this in the morning itself. 01111. 3. You will get 11 as the result. 11 as the binary equivalent. 0011. We wrote it as 0011 because any number of zeros to the left of the number would not affect the value. You can add any number of zeros. I added 2 zeros to the number. Okay. Then We told you about what? Imaginary, complex, complex. I call you, just look at this complex, complex. I wish to say 3 plus 5y, 3 comma 5. See what happens. It is written as 3 plus 5y. Okay. Then equals im abs. The absolute value of these two components would be written as 5.83 because it is equivalent to 3 square plus 5 square. 3 squares, 3 square plus 5 square would be 9 plus 25. 9 plus 25, 34. 34, square root of 34 is 5.83. Okay, 5.83 is the result we get for IMAPS. Then IM real, real part alone, IM real of B5. I'll get 3 as the result. Then imaginary, the imaginary part of B5. I'll get 5 as the result. Okay, that is, there is one complex number which has got two components. One is the real, other one is the not false. It's real versus imaginary. Real, imaginary. 3 plus 5y. 3 is the real part, 5 is the imaginary part. Then I call several functions. I say real, im real gives me 3 as the result. Im imaginary gives 5 as the result. Imax gives me the absolute value of these two. Absolute value. Whereas I am not teaching you mathematics, I cannot go beyond this in imaginary numbers. It's very easy, whereas we don't have much time for discussion about all those things. You just take a look. You take this, you draw this. It's a graph sheet. 3, 1. We would type 1, 2, 3. Okay, then sorry, 3. And here we go on typing other numbers. 5, 4. No, it's graph sheet. We are creating a rudimentary graph sheet. It is plotted on a graph sheet. Wait. And this 3 plus 5y is equivalent to marking this point. It's equivalent to marking this intersection between the real component 3 and the imaginary component 5. We start with 3 and go up to 5. This is the point we represent through 3 plus 5y. With this, we close all engineering function. Okay.